Hi everybody, it's Miss Dupree. In this lesson, we're going to explore plate boundaries. You have already learned that Earth's rocky material can be divided into two layers, the lithosphere and the asthenosphere. The lithosphere, which is made of Earth's crust and the very top part of the mantle, is made of hard, unmoving rock, and it's broken into several massive chunks called tectonic plates. And the tectonic plates are floating on top of the asthenosphere, which is made of the rest of the upper mantle. And as heat from Earth's core moves up through that asthenosphere, convection currents form that cause the asthenosphere to start moving. And as the asthenosphere moves, those tectonic plates floating on top also move. And this is what causes a lot of different geologic activity on Earth, including volcanoes, earthquakes, mountain formation, ocean trenches, and the creation of new crust and the destruction of old crust. So one thing I want you to know is that most geologic activity happens at the sides or the edges of the plates, which is where two or more plates come together. And these are called plate boundaries. The word boundary means the edge of something. So plate boundaries are the edges of the plates. And that's what's shown here. And these different red and yellow lines are the edges of the different tectonic plates. This is the Pacific plate right here that we're looking at. This is the North American plate. And so these lines represent the edges where the plates are coming together. And that's actually going to be where most of the geological action happens. And that's because when those plates are moving, sometimes they bump and grind against each other. So if you look at this tectonic plate map, you'll see that the plates move in different directions. Sometimes they're pulling apart from each other, and sometimes they're pushing together. And there's other times where they're kind of moving like side by side past each other. And even though the plates move really slowly, they only move a few centimeters per year. That's about as fast as your fingernails grow. These tectonic plates are just so massive that when they do move, huge things happen up on Earth's surface. So there are three ways that tectonic plates can interact at plate boundaries. And in today's video, we're going to look at one type of boundary that's called a convergent boundary. In a convergent boundary, two tectonic plates are moving toward each other or pushing together. And in a convergent boundary, two different things can happen depending on the types of plates that are pushing together. So the first type of situation happens when you have two continental plates that are pushing together. Now, continental plates, they're those thicker plates because they're holding our continents. They're going to have pretty much the same density. So when they push together, the rock squeezes together, and because it doesn't have anywhere to go, it goes up, it pushes up. And as these plates move up, this causes mountains to form. Now, it takes like many millions of years to make a mountain, and that's because these tectonic plates are only moving a few centimeters every year. But over millions and millions and millions of years, that adds up to a lot of centimeters. So one example of a continental convergent boundary is the Himalayan mountain range, one of the tallest mountain ranges. It's actually also one of the youngest mountain ranges. And what's happening is that the Indo-Australian and the Eurasian, both of those continental plates, they're pushing together, and that's causing the Himalayan mountains to grow larger. In fact, they're still growing today, still getting larger. So another type of convergent boundary happens when you have a continental and an oceanic crust that push together. And in this case, the oceanic crust, which is thinner and more dense, remember, more dense is going to sink, go down. So the oceanic crust sinks and it gets pushed underneath the continental crust, which is what's happening right here. Now, this is a special process. It's still a convergent boundary, but it's called subduction. And I like to remember that submarines, the sub in submarines, that submarines go down under the water, and in subduction, which is also a sub, the oceanic plate goes down underneath the continental plate. And as that oceanic plate gets forced down, it gets hotter and hotter until it melts, and then that crust gets destroyed. At the same time, that continental plate can get squeezed up, and that's going to cause just so much different geological activity. In fact, this is why subduction zones are one of the most geologically active and violent types of boundaries. You're going to find a lot of volcanoes in subduction zones because you've got the melted oceanic rock right there that can get pushed up through weaker spots in the crust. They're going to have lots and lots of earthquakes. And then because we've got ocean right here, when there are earthquakes happening in the ocean, then they can have tsunamis that can form. So that's subduction zone, the second type of convergent boundary. So your main idea for this lesson, this video, should be that one of the types of plate boundaries, which is convergent boundaries, happen anytime that two plates are pushing toward each other. And there are two types of convergent boundaries. One where both plates push together and go up, and then one, the subduction zone, where one plate gets pushed underneath the other plate. So that's it for this lesson. In the next lesson, we'll take a look at the other two types of plate boundaries. But that's it for today. If you have any questions, please ask. Otherwise, you're all set. Good job, everybody. See you next time.